Have you ever wished you could have a real conversation with Garfield, the world's most sarcastic and lasagna loving cat? Well, now you can. Using Google Gemini's 1.5 Flash Pro, a cutting edge large language model, we have replicated Garfield's personality, tone, and humor, making it possible for anyone to interact with him conversationally. Thanks to Google Gemini's long context capability, with the ability to process up to 1 million tokens, we have fed the model 7 years of Garfield's comic strips and several hours of videos. The result? A Garfield who responds with rich, nuanced knowledge of his true character. So, how did we do it? We used 5 of Gemini's capabilities to extract Garfield's quirks. We used image or video to text conversion capability, context caching, many-shot training, multi-turn chat, and structured outputs. Here's the flowchart of the entire model end to end. In this model, we have the brain and the body. Let's first talk about the brain. This is where Garfield's personality comes to life. We utilize 3 Gemini models to craft his essence. The first is the personality extractor model, where we use Garfield's comic strip and videos, transforming them into structured text to decode Garfield's personality. Next is the personality generator model, where we leverage Gemini's many-shot training to flip Garfield's personality, making him hate lasagna and love broccoli. Yes, we did that. We then cached the contents of the personality extractor model and then fed the contents from the extractor model along with the data generated by the personality generator model into our Gemini's personality engine. We now have a personality engine capable of mimicking Garfield's thoughts, processes, dialogues, actions, and rationale. Now let's talk about the body. We also created a WebGL application in Unity where you can interact with Garfield's model in real time, experiencing his personality firsthand. Due to Kaggle's environment limitation, you can access the interactive model through an existing Colab notebook that we have linked towards the end of this notebook. We use Gemini API file upload capabilities as we had files greater than 20 MB to upload our large files to Gemini servers, and we use the file identifier downstream to refer to this file. Here we are extracting Garfield's personality. We needed this extracted data to be stored in a structured format for easy analysis. So in this cell, we define the output structure and ask Gemini to give a response in this structure. This is the very first Gemini model configuration. We have explicitly asked Gemini to give outputs in JSON format, mapping the responses to various situations. We set the temperature to 0 to make sure that the responses are deterministic, and we also extensively experimented with system instructions, taking advantage of the flexibility they offered. In this step, we defined Gemini's generative model by specifying the model name, system instruction, generation configuration, and the safety settings. Here, we perform data cleanup, pre-processing, schema flattening to significantly reduce the token count while maintaining the context. This optimization allowed us to bring the token count down from 2 million to just 400,000, ensuring data efficiency without compromising on the richness of the context. Google Gemini's context caching feature allowed us to improve speed by reusing pre-computed input tokens. To cache our content, we needed to provide the model a display name for easy cache identification, the system instructions, and the content to be stored. We leveraged Gemini's public knowledge to create synthetic data for many-shot training. To achieve this, we clearly defined the requirement and asked the model to output in JSON format. This JSON format aligns with our needs. The model is then guided by system instructions to generate unique and varied training examples in JSON format, mimicking a user-model interaction. The function returns a list of these synthetic examples, which can then be used to augment training and improve model performance.
So far, you have seen the brain. Finally, it's time to see Garfield in action. Let's see how Garfield reacts to few of the props found in the Garfield universe on the left side of the screen. Now let's select a plate of lasagna. So now you can see, based on your selection, Garfield's personality engine kicks in and delivers a response that is uniquely his. On the bottom right, you can see his chain of reasoning, providing insight to what his thoughts was and how he came up with that. Now let's personalize the experience with Message Editor at the left bottom of the screen. This feature lets you chat with Garfield. Do you like pizza or broccoli? You can see that he obviously liked pizza. In conclusion, this framework is a flexible starting point that uses Gemini's long context abilities to build a generic personality model. In the future, it can grow further to include a wide range of unique and diverse personalities, thus unlocking even greater adaptability and depth of Gemini long context.